Okay, so welcome to the second talk this evening in our themed night about decoupling. I'm going to be talking about decoupling using events. My name, for those who don't know me, is Dave Liddament, and I work for a company called Lamp Bristol, and that is our office. So first of all, why is decoupling important? We want loosely coupled code. Coupling is basically how much the code knows about other bits of code that's going on. So as Dan sort of said in his talk, we don't really often need to know the details of what's going on. You know, we just, at a very high level, I want you to log something, and I don't really care about how that logger actually puts the thing in a log file or does whatever it does. So let's look at some code. So this is a user controller, and we're going to look at a function for registering a new user. So we're going to assume that there was a form, some HTML, people typed in details for the new user, and it gets routed through to this controller. So the first thing the controller is going to do is extract the data from the form, and then we're going to create a new user in the database, and then we're going to send a user confirmation email via Mandrill, and then we're going to return some reference to a template, some HTML that says, yes, we've now registered for the system. So pretty standard functionality that we want to achieve. I'm sure we've all written stuff like this or worked on code like this. So what's wrong with that code? Well, there's two big problems with it. First of all, this kind of code here is nothing really to do with the controller. What if somebody came along and said, we're going to register users through some other means? Maybe we're going to have a REST API, or maybe we're going to use command line interface to read stuff out of files, a list of users out of files. Suddenly, the code that we want to create a new user and send the confirmation email via Mandrill is all stuck in this controller function, or method, which means we can't really reuse it. Another one is we can send the confirmation email via Mandrill. Well, what happens if we don't like Mandrill? What if we want to change to another email provider? So these are things that are wrong with user controller, and we've basically got the controller has got knowledge of how we're creating a new user or how we are sending email, and it doesn't really need to know that. It can just delegate that off to some other service. And equally, when we're sending the email, the code that sends the email, we don't really care how that email gets sent as long as it just gets sent. So if we make our code loosely coupled, where the controller doesn't know these things, it will be a lot easier to reuse that code in future. So maybe we make a user registration service, and here's the interface to it, and it's just got this one method, register user, where you pass to it the user object. So then our user controller becomes a lot more simplified. It's just focusing on what it needs to do, and then we're delegating anything off to the user registration service. And then we can reuse that code elsewhere. And then equally our email gateway interface, again, we're just going to send an email to a single method, send email, and we'll pass to it an email message which will contain, who we're sending the email to, what the subject is, or the context. So that's why we want to decouple things. It means the code is reusable elsewhere. It means the code is focusing on just what it needs to do. And if we want to do things like swap out how we send emails, we just swap out the implementation of that. Everything else remains the same. So so that's why decoupling is important. And Dan's been talking about dependency injection, which is a very good way of joining together all these decoupled things. And I'm going to look at how we can use events for that. Now, events is just another way of doing it. It's not necessarily the best way of doing things in some circumstances. So it's just another tool to have in your toolbox. Don't go away and write code that only uses events to join together all our decoupled things. That's probably not the right solution. But there are use cases for events when it is good to use them. So it's just another tool in our toolbox. So what is an event? So an event is just like an action that our software may react to. So it could be a mouse click. User click the mouse on something, or it could be something we've registered a new user or an order's been processed. So an event could be something So details about event, there's normally a type, so it could be a mouse click event, it could be a new user registration event. We might give the event extra data, so in the case of a new user registration event, the data we might pass into it is, here's the new user we've created. And I'd say you shouldn't have any logic in the event, it should just be like an object that holds data. And then event processing. So the first thing is we've got some code which is a dispatcher. So it says something's happened, so I'm going to fire off or dispatch an event. So that's the event dispatcher stuff. And then over here we have some code that are listeners, and the listeners say I'm interested in listening to certain types of events. And then we've got our event handling logic that basically just links those two things together. So what I'm talking about for this talk is only basically synchronous events. So if we imagine our event dispatcher over here says, right, I've registered a new user, so I'm going to create a new user event. I'm going to dispatch that off. And let's say there's listener number 1 here goes, yeah, okay, I'll handle that, I'll do whatever I need to do. Great, I've done that. And then listener is also listening for that event. There's the second one goes, I'll go and do a bit of that. And then when they've both finished, control passes all the way back to the code that dispatched the event and moves on to the next line. So yeah, I'm just talking about synchronous events today. Other properties the events or the event handling software might have, there might be the ability to set a stop propagation flag. So our event dispatcher sends off an event, and then one of the listeners goes, yeah, okay, I'm processing it, or I've done everything to do with that event, so I'm going to set the stop propagation. And that means if there are any other event listeners that might be listening out to this event, they won't get it, because basically my listener has said, I've done all you need to do with this event, so there's no need for it to go anywhere else. And then control will return over to the code that dispatched it. Also, you might have a system where you can define the priorities of the event listeners, so you can then have the highest event listeners going first, which might be useful in some, to define the order. If you don't have priority, or 2 event listeners have the same priority, then you can't really make any assumptions about what order they'll be triggered in. So how do we join these things up? So imagine we've got the blue is the event source there. So this could be somebody's clicking on my DOM element or something like that. And the event listeners, what they might do is they might say, I'm just going to register myself with that event source, and when an event occurs, the event source goes, who are all the people that are listening to this? I'll just send off to them to say this event has occurred. And there's a level of decoupling here. The event source doesn't really know or care who's listening to it. It will just have some kind of way of registering the event listeners, and it will just fire off the events there. It won't care if any of them are listening or not. So there's some level of decoupling. And the other one is you might have an event bus, and this is a higher level of decoupling, really, because the event sources and the event listeners are all attached to an event bus. So if an event source sends out an event, it just passes it onto the event bus, and then anyone who might want to listen to it is listening to it from the event bus. The event bus passes on the event. And equally, the event listeners, they don't even know where these events are coming from now. They just say, I'm interested in a certain kind of event, I'm interested in a register a user event, and I don't care who fires off or dispatches that event, but I just know how to handle it. So this is quite a decoupled way of doing things. So let's look at a few examples of this in action. So the first one is actually a JavaScript example of something I worked on a while ago. I was trying to get a screenshot of it, but it's not on the internet now. I think I did it in about 2008, and nobody's using it anymore. And what it was is we had a load of data we would visualize on maps, and we wanted to show an easy way of people comparing that data. So we had, you could have 2, 3, 4 maps. Because this was 2008, you couldn't really have more than about 4 maps because the browsers couldn't cope with it. And all the maps had to be centered on the same area. So if you were looking at the center of Bristol, all of the maps would be centered on the center of Bristol, and each map would be showing a different data layer. So it might be, map 1 might be showing you perception of crime. Map 2 might be showing you the actual crime rates as heat maps and stuff like that. And people could use this to look at the data, and it really brought the data to life. And what we needed to do is, if somebody interacted with the map, we need to make sure that all the others are kept up. So if I came along and scrolled map 1 upwards, all the other maps had to scroll upwards as well by the same amount. And if I interacted with map 2 and scrolled it to the left, all the others had to scroll to the left at the same amount. So the way we implemented this was we joined everything to an event bus, and the maps could both send and receive move map events. So if map 1 had its map, somebody dragged the map around, we'd say, here's it would emit or dispatch a move map event and say, and the new centre location of the map is X, Y. Send it to the event bus, and all the others would be listening out for these events, and they go, oh great, okay, I now need to move, to update the position of the map. And of course, it didn't really matter how many maps you could have. You could easily have a 4th map on there as well, or any number of maps. So that was quite a neat use case of events. So now let's go back to our user's PHP example now, our user registration code that we looked at the start. And this is the kind of code that you're probably going to use time and time again on projects. So we basically wrapped it all up, imagine this, we wrapped it all up, we put it into a library, and then we released the library, a user registration library, and it was there, and it could be used by lots of different projects. And that's all going really well. And then imagine a client comes along and say, oh, that's really great, but I'd really like to be able to do something more with that. I'd really like to be able to, when we register a new user, I'd really like to send them a voucher code, personalised for them, which they can use to get, say, 10% off their first purchase. And there'll be loads of things like this. You have your generic solution, and then, depending on the application, have different kind of extra bits of functionality that you want to hook in. So, what do we do here? Well, we could go and modify our library code and put in some extra functionality that did this, but it's not going to be used time and time again. Let's just imagine for this example, it's really specific to a particular client. So instead, if this is a case where we could use events to help us to help us extend new functionality. So what we could do is we could say, well, look, let's have a new registered user event. And it would look like this. We've got, we'll just hold the user, so we'll construct it, passing in the user that we've just created, and then there's the ability to get user. So this just holds, by its name, it gives away that it's a new registered user event, and it just holds data about the new user that we've just built, that we've just registered. We have to make one tiny bit change to the existing code. So what we're going to do is, this is our existing registered user service, and once it's created everything and sent the emails, what we'll do is we'll just create a new registered user event, and then we'll dispatch that to the event dispatcher, and that will send it off to the event handling code. So we made that change, and maybe no one's listening to that event. In all the other cases, nobody cares about this. But in this particular project, where we need to create a voucher code, we are listening to this event. So we might have some code that looks a bit like this. So we've got our voucher code sender class, and we've got a on new user registration method, which takes the event. We can get the user out of the event, and then we can do whatever code we need to create the voucher. Now, if this was real code, I would say this should delegate off to something else that actually creates the voucher. This is just here to listen to the event. And if we were using the Symfony framework, this is from the config file. It's like 15,000 lines long. And what we need to do is we just need to add in just this bit in yellow to say, I've got an event here. I'm basically an event listener, and I'm listening out for the new user registration event. And that will wire it all together. Now, there's lots of other event frameworks that will do this kind of stuff, but I use the Symfony framework mainly, so this is the one I know. But the point is, it's quite easy to add this stuff in. And what we've got now is we've got a system where we've got some existing code, and we've got a nice clean extension point. So if, for example, we want to do any kind of processing after the user has been registered, we just put it in and it listens out for that event, and we can put the code in there. So this is a bit like the open solid with the open close principle, where your code should be open to extension but closed to modification. Okay, we did make a tiny little change to our library code, but that wouldn't be a backward compatibility breaking code. It's just change. It's just to add in the ability to send that message, to send that event. And once that's there, we can use that library and any other kind of requirement that a customer has. We don't have to go back and change that library code. We just hook in to the event and put the functionality in there. So it's quite powerful for that. Does that kind of make sense? Use case, yeah, brilliant, cool. What I'll do is I've just got some bonus slides. So this is another example. So events might be used a lot more than maybe you think. So all of the major like heavyweight frameworks like Laravel, Symfony, and Zen, they basically all use events behind the scenes. So in Symfony, when you make a request that comes in, basically it creates a kernel, an HTTP kernel. And what that actually does is that fires off a series of events, and then you have other things that listen out to those events and kind of dictate what happens. So the first event, for example, when a request comes in, is called the request event in Symfony. And Laravel and Zen have very similar kind of setup to this. And in the case of Symfony, the request one does things like it has event listeners for things like session data. So it works out if there's a session cookie and then loads session data into the request. It does things like working out the routing, so which controller should handle the request. And it's got a firewall as well to determine has the person got access to this particular thing. And all these things are completely pluggable. You could get rid of the Symfony router and put your own router in. You could get rid of the Symfony firewall and put your own firewall in. And all you basically be doing is saying, get rid of the Symfony one, I'll write my own or use some other, and I'll just hook into that request event. And everything else stays the same. So we've got this quite nicely decoupled thing here. You know, the kernel is just there for responsible for sort of working through the steps of handling requests, but how each of these steps are handled is, you can change that. So the one we're going to look at now is the terminate event. So what basically happens is you go through all these steps, and by the time you've finished the finish request, we have sent back all the data to the person who's made the request. So, and the terminate is basically to be run just before we shut down. So imagine we are sending an email as part of our request. So going back to our create user thing, remember the first thing we did was we stored the new data into the database, and then we went off and sent an email. Now, generally when you're sending an email, you will probably be making some kind of network request, and generally that's going to be a lot slower. So this is how long the person has to wait. They come in, this bit's really quick, putting it all in the database. Then we make another request out to however we send our email. Maybe we're hitting an API, or maybe we're making an SMTP request. That takes a long time relatively. Finally it comes back, and then finally we return our response to the user. But actually, all this stuff is dead time, and we don't really need to keep whoever made this request waiting. So what we can do is we can do something like this. So the request comes in at the start. We quickly say, oh, by the way, I'm going to have to send this email, but we don't actually send it. We finish doing everything we do, we return. So this is a really quick request. You know, before, it was taking the whole screen, and that's a lot of time. Now it's just taking a little bit of the screen, and that's really quick, because we're not doing this request until later. And then what's happening on the blue bit here is we have an event handler that's just listening for the on-terminate event. And then Symfony says, here's my on-terminate event. And then it goes, great, I'll do this, and here's where I'll actually go and send the email. And this could be any long-running task that doesn't have to be done as part of the request. For example, if we're uploading an image, maybe we do some processing on that image, we can do it here and not slow down the person making the request. Or it could be anything else, you know, any kind of network request, any kind of long-running generating PDF, something like that. As long as we don't need it available to complete the request, we can defer it to later. So, what do we have to do with our existing code? Well, let's remember what we had for sending an email. We refactored it, so we had basically an email gateway interface with just the one method, send email. We pass it the email message. So the real implementation to send the mandrill thing might be something like this. We've got an implementation of it, and then we've got the code to actually send it. Again, we could replace this with any other method of sending emails. And now we've got our on-terminate email gateway. Again, this complies with the email gateway interface. So anyone sending an email, obviously they're sending it to the email gateway interface, but actually we'll be using this implementation of it. So first of all, we'll keep a list of all the emails that we need to send. Then when we send the email, instead of actually sending it, we are just going to add it to the list of emails that needs to be sent. And then finally, we've got the on-terminate event, and basically that goes through the list of emails, and it actually goes and sends the email. Again, we're just using the email gateway interface. So that would, if I had all the code here, that would be injected in the way we actually send the email. So again, we've kind of got, that's another example of where, when people were developing the Symfony framework, they probably thought that it might be used for this event, but when it sends a terminate event out, maybe something's listening, maybe something isn't. But if something is listening, it provides a nice hook point for you to do things like this. So let's go back to our... So that's basically what we've done there is we've kind of decoupled a lot of things. We said, I want to send an email, but how that actually gets sent, I don't mind. And then Symfony has said, well, I'm about to close down the request, but if you want to do something before I close down the request and after the response has gone back to the user, here's your opportunity to do it. Symfony doesn't care if anything goes then, but you can take advantage of it. So the pros of using events, it can help you get decoupled code, and it's quite a good way for doing extensions as well. So like if you've got some kind of library and you might want hooks for other bits of functionality to hook into, you can basically fire off events and other bits of code can listen for those events and do processing at that point. But it's not all great. It's less obvious what's going on, and this, whatever event framework you're using, there probably are tools there to tell you what events are registered and who's listening to what, because you're not in code where you're using dependency injection. You can just, if I'm using PHP Storm, I can see all the things that implement, say, email gateway interface, and I know it's going to be one of those things that is, that is actually being called. Whereas this, you could be firing up events and you have no idea who's really listening to the events. It's harder to track that stuff down. And that's because it makes it harder to debug. So I would say only use events if you cannot use something else. And the final one is maybe no one is listening. Let's say we did something like, whenever we wanted to log something, instead of using something that complied to the log interface, we just fired off an event, a log this event, log message event. We could have misconfigured our system such that nobody is listening for that log message event. And that would be quite difficult, because generally when you're logging something, it's because you need to tell somebody something's gone wrong, or you maybe using it for debugging. And if you haven't got an event listener that listens to the log events set up, then the log, I'll just fire off this log message and nothing's happening. So if somebody has to be reacting to it, then maybe events are the best use case for this. So in summary, decoupling is good. Events could be a way of doing decoupling. They're good for extension points, but they are no silver bullets. And what I've discussed here is only basically the start. There's so many areas you can talk about events, but this is just an introduction to it. If you want to find more about the Symfony event dispatcher, you don't have to use the whole Symfony framework. You can just use it as a standalone bit of code. It is actually quite simple what it does. You could write your own event dispatcher, but some people will done it for you. And there'll be other things like that. So, any questions? Is anyone still listening? Yeah.
The last slide you showed the disadvantages. If you had an event stream, surely those disadvantages they wouldn't be applicable.
Yeah. So if you're doing like event sourcing and everything like that, yeah. So, but then you are doing an architecture that's very different.
Outside of
yeah.
Right.
If that was your architecture, then obviously you would have. So you can basically have a system where everything's an event. And if you want to learn more about that, I think someone did a talk last year about that, event streaming and CQRS. Is the video on? Yeah, but that's a very different way of handling things. I'm just talking about server, right.
I think one more consequence, one tricky part with the event is the error handling. And
yes.
Handling failures.
If something goes wrong with the events,
what would be your preferred approach? Let's put it that way. If you have to use events.
So because they are synchronous, then the event will just bubble up to where, if you haven't got any, if you're not catching whatever the exception is, it will just bubble up. So it'll bubble back to the code that dispatched it, and then eventually it will bubble up to the framework if you haven't got anything specifically to capture it.
Yeah, but the actual stuff on the terminate event, right? How would you would be able to notify the user about
that? So on the Symphony thing, yes. If you well, there's another. So Symphony offer an exception hook, and I think I can't remember what order they go in. I think if you have an exception in terminate or an exception in exception, then it won't bubble. It won't bubble. You should basically catch them all and deal with them properly. You should certainly catch any exceptions that happen in the exception handler.
And then the code that actually dispatched the event probably wouldn't know which one of the listeners threw the error, or if it knows, probably then it's not that decoupled anymore.
Yeah, I mean you could get it from the stack trace, but yeah. I think you should probably catch the events and you code flag or something like that. If it's something that somebody else can handle, then maybe exceptions aren't the best use case necessarily there. You could have something like more.
My personal preferences about events are to use them only for asynchronous stuff.
Which we haven't even discussed yet.
Yeah.
I mean, you could do all these...
Because of the error handling. Yeah.
But then, yeah.
So, in the glory days, when we did everything with, WordPress and Joomla, whatever, and Gallery 2 and things like that, this exact implementation was called plugin hooks.
Yeah.
Do you think that's a fair way of categorizing the best use case for this kind of thing?
Well, there might be other good use cases of events, but it certainly is used for those kind of things. Yeah, I mean, I would say Drupal hooks is a very similar concept. They're not implemented in exactly the same way, but I don't know about those.
But that process of, I can say, I'm ready to receive control panel options, but something else says, I've got some for you. That was always the way plugins were implemented.
I see, so it would send off an event saying, tell me about all your things you want to, and then dispatch code.
And I'm just thinking, obviously for debugging reasons, first and foremost, you wouldn't want to design your whole application. You said that you wouldn't want to do everything with events.
Yeah.
But is that the sort of use case where it's really, in your experience, where you're just bolting things onto the side?
Yes. So the other main thing I've been using it for recently is we basically process a message, and there's several different things that can handle the message in order of priority. So what I've done is I've made an inbound message event. I've got all of these things at different priorities to handle them, and when certain things are enabled, they kind of fit in between them. So you might have, in normal process, you might have this one, but then when a certain plugin's enabled, it jumps in there. So yeah, that's another use case for it.
And then presumably that would stop propagation?
Yes, yeah. So once they've handled it, they do actually stop propagation, Final question.
Yeah, kind of jumping back to your talk in February, so you talk on automated testing. We've had this idea of a spectrum of system tests all the way down to unit tests as well. So obviously with this, you're decoupling the logic, or the events as well. But at the same time, do you find that kind of pushes back from the unit side of the scale back to the integration side of the scale to make sure you've got your event listeners set up correctly?
Yeah, so what you'd want to test at unit test level is, there was that code where I said, and in reality I'd defer all that off, So I would have very lightweight event listeners, and they would just defer off to somewhere else. So you can do most of that functionality testing at the unit test level. But then if you want to test everything's wired up correctly, there is no other way of doing it, as far as I'm aware, other than actually, putting the system in a state where it will work through, which is why it takes longer to test and more difficult to write.
It's just, if you wouldn't fire enough that event before, theoretically you could use dependency injection, you could test pretty much everything, but obviously now this is adding that event firing loop to make sure that extra things are wired up. So you're actually pushing it back at that scale, but it's whether that's a good kind of trade-off, I suppose.
Yes, and you have to be careful, because you can, with events, you can put data into them, so it might, the simplest thing is the dispatcher puts some data into that event and it is basically immutable, nothing ever changes it. But they are sometimes used where various bits put data into it, so then you've kind of introduced some kind of coupling, so it's not as decoupled as you might first imagine. And of course that makes it more difficult to test, and if you mess up the priorities and things go wrong and stuff like that, so Is it a nice question? You always ask difficult questions.
Even in these simple examples, is the code truly decoupled, or is it still coupled, but in a way that's much more difficult to reason
I said last question, I should start.
Never let him ask a question.
I know. So in these examples, there's extra decoupling to whatever your possible coupling to your event processing thing. So if you're using the Symphony thing, then you are coupled, they all extend the Symphony abstract event. So there's additional coupling there.
But you're still assuming that one thing over here is going to result in a thing over here happening.
Yes, you are. But maybe that is valid in some cases. Like, the case of, like, I want to have some extra behaviour that happens after the user's registered. I suppose that behaviour is assuming that somewhere else will actually fire this event at the right time. So yes, there is coupling on that, but and it's, as I say, it's less obvious what's going on. But I don't know if I've answered your question. Brilliant.
So it's a trade-off.
It's a trade-off, yeah. Thanks. Any more? Great. Okay. Well, let's. Go ahead.